Self-training. Self-training is a semi-supervised learning approach that leverages a small labeled dataset alongside a larger unlabeled dataset. The model is initially trained on labeled data and then it makes predictions on the unlabeled data. The confident predictions, those with high certainty, are then added to the labeled dataset and the process is repeated to improve the model. Let's go ahead and build this code in Python to see how this can be done. So let me open my IDE, and here I've already created a file called as selftraining.py. Now here, first step is to import the necessary libraries. So I'm going to go ahead and start with my libraries. First, from sklearn ensemble import random forest classifier. This imports the random forest classifier class from scikit-learn's ensemble module, which is used for supervised classification tasks. Next, from sklearn.datasets, import make classification. This imports the make classification function, which generates a synthetic dataset for classification tasks. Next, from sklearn.model selection, import train test split. This imports the train test split function, which splits a dataset into training and testing subsets. Next, from sklearn.metrics, import accuracy score. This imports accuracy score, which calculates the accuracy of predictions. Finally, let's import numpy as np, which imports the numpy library for numerical operations like array manipulation. Let's go ahead and generate a synthetic dataset. So I'm going to say x comma y make classification, n samples equal to 200, n features equal to 5, random state equal to 42. This generates a synthetic dataset with 200 samples and 5 features using random state equal to 42 for reproducibility. Next, let's say x labeled, x unlabeled, y labeled equal to train test split x comma y test size 0.7 random state equal to 42. What this does is this splits the dataset into labeled and unlabeled portions, with 30% labeled for initial training and 70% unlabeled. X underscore labeled and y underscore labeled hold the labeled data, while x underscore unlabeled contains the unlabeled data. Its labels are ignored for the self-training approach here. So let's go ahead and initialize and train the model with labeled data. So I say model equal to random forest classifier, random state equal to 42, which will initialize a random forest classifier with random state equal to 42 to ensure reproducibility. And then I'm going to say model.fit x labeled, y labeled. This trains the model on the initially labeled data. Now let's go and perform self-training on unlabeled data. For this, I'm going to say for underscore in range 5, which sets a loop to repeat the self-training process 5 times, allowing the model to iteratively expand its labeled dataset by adding confident predictions. Next, go ahead and predict the probabilities of unlabeled data. So I'm going to say props equal to model.predictproba x underscore unlabeled. This uses the model to predict class probabilities for each sample in the unlabeled dataset. Next, I'm going to say high confidence IDX or index equal to np.where np.max props axis equal to 1 greater than 0.9 of 0. What this does is this finds indices of samples where the model's maximum probability exceeds 0.9, including high confidence in these predictions. So that's what this does. Next, I'm going to say add high confidence predictions to label data. To do that, I'm going to say x labeled equal to np.vstack and pass it x labeled comma x unlabeled high confidence IDX. This adds the high confidence samples from x underscore unlabeled to the x labeled data set using np.vstack. Next, I'm going to say y labeled equal to np.hstack. And what this does is this adds the corresponding predicted labels for these high confidence samples to y labeled using np.hstack. Next, I'm going to remove confident samples from the unlabeled dataset. To do that, I'm going to say x underscore unlabeled equal to np.delete x unlabeled high confidence IDX and access equal to 0. So this will remove the confidence samples from X unlabeled, leaving only uncertain samples for the next iteration. Then I'm going to say retrain the model on expanded labeled dataset. So I'm going to say model.fit X labeled and Y labeled, which retrains the model on the expanded labeled dataset, incorporating new samples from each iteration. Now finally, or final evaluation of a test set. To do that, what I'm going to do is I'm going to say X underscore train X test, Y train Y test, train test split, and to this pass X comma Y test size equal to 0.3, random state 42. This splits the original data into a training and test set, 70% for training, 30% for test. Then I'm going to say model.fit, which trains the model on the full training set. Then I'm going to say ypred equal to model.predict X underscore test. This predicts labels for the test set. Then accuracy equal to accuracy score, which computes the accuracy on predictions on the test set. And finally, I will print the accuracy. This prints the final accuracy score, providing a performance measure for the self-trained model. Let's go ahead and run this particular project. So I'm going to save it and open my terminal. Inside my terminal, I'll say python self-training.py. And there you go. It shows me an accuracy of 0.8833, which is pretty good. And hopefully you were able to follow along and implement this. If you had any issues or problems, let me know and I'll get back to you.